I'm CK. Tonight we're going to be doing another eurorack module. Tonight we'll be starting a Befaco voltage controlled ADSR or note envelope generator module. I like the two Befaco modules I've built so far, so I needed a new envelope generator, so I figured I'd give Befaco's a try. This will probably be a multi-night kit, so we'll give it a look-see and then dive into building it. Hope you enjoy it. So let's dive in and see what's in the bag. We've got the paperwork, and inside that, as is typical, we have the front panel with trigger and the output and the shaper and attack, decay, sustain, release sliders. Looks like LEDs right there, some state gates and control voltage ins. Then a Befaco circuit board. As you can see, it's two circuit boards built on the same die. I'm sure it was cheaper to do that. As is consistent with Befaco in my experience, the circuit board is good, nice through-hole plated connections and decent silk screening, but as I've mentioned in the previous Befaco units, they pack a lot of stuff together, so sometimes it's hard to read some of the silk screening, and if you're not hugely experienced soldering iron hand, you may have trouble with some of the closeness of the fit. But it looks like, and in this case it also looks like they're packing the back of the board as well as the front of the board with components, so it'll be an interesting thing to build. Now they do label their bags, some of their bags, the electrical components primarily. So this is for the main board, bag A. Here's the jacks and the very attractive panel nuts that Befaco uses. I really like those. Here we've got 1, 2, 3, 4, 5, 6 ICs and their associated sockets. A bunch of general componentry, some transistors, capacitors, the eurorack cable connector, and that's the main board, bag B. Here's some mechanical stuff, the gnarly panel mounters, screws. These little red caps, I'm going to assume are the caps that go on the sliders for ADSR. A knob, a Befaco panel nut wrench with little projections to screw it in without messing stuff up. Of course, since this is my third Befaco unit this month, that means it's my third panel wrench. I'm going to build a house with them eventually. Control board, bag A, more passive electrical components and LEDs again, and I'll show these when we get to put them together. The tapered or shouldered LEDs that Befaco likes to use. And then here's a whole bunch of mechanical components, including the sliders. Let me take one out so we can take a look at this, because I didn't know what kind of sliders they were going to be using. So here's a slider. It's a 100K ohm slider, So it's 0 to 100 kilo ohm resistance. Slides up and down like so. It feels pretty good. It's a little stiff, but that's not bad because it's not going to go anywhere. I'm actually surprised at how long the slider handle is. That's 3/4 of an inch, almost 7/8. I think I may know why. I think it may, well, I'm not going to speculate, but in any case, that's longer than I expected them to be. Put them back in the bag so I don't lose them. And that's got other things, standoffs to connect the boards together, switches, both toggle and push button, and potentiometer for the shaper. All looks good. It looks like a 2-night kit. And the final thing in the bag, of course, is a eurorack power ribbon. So the first thing will be to separate the circuit boards from each other. Sometimes they just pack a little bit too much in. This solder pad and this solder pad are actually cut off. I mean, that's way too close to the edge. I wish they would. I know they want to get the horizontal spacing as small as they can, but I mean, give it things a little bit more breathing room. Now, I like to sand these down. You don't have to, of course. Yeah, that's just wacky. Again, if you look here, you can see the plating right there. You could push right through on those. They're way too close to the edge of the board. Their design choice, and as long as it works for me, in the end, it's okay. We're going to do main board bag A first. Befaco just puts the designator, like C1 for capacitor 1, R13 for resistor 13, and so on. They don't put the actual values. Some kit builders put the actual numeric value of the component in there, which can be handy if you get instructions that are in a different language from one you read, or don't get instructions at all. Interestingly, they do put the IC part numbers on the board, just not the designators for anything else. Okay, we're going to open main board bag A, and it's all the passive components, bunch of resistors, bunch of diodes, and ferrite cores. Now, as we've seen in other videos, Befaco likes to use ferrite cores in the power along the power system, and that's fine. The only thing we have to remember, of course, is that means we have to harvest a couple of resistor leads to put the ferrite coil on the board later. So first we've got 6 100K resistors, and that's brown, black, black, orange. I think that's right. Again, these olive drab resistors, it's a little harder for me to see the colors on, so I do what I always do when all else fails. I put it on the meter just to be sure. Yep, those are our 100Ks. So that's all the resistors, and about halfway through I switched my soldering tip to my small angle tip that I usually use for surface mount, but the pitch on these components is, again, so tight that I wanted a little more precision. I don't use that tip all the time because it's not a official Weller one, and while it works okay, the temperature swings 10 to 15 degrees plus or minus what I've set all the time. Like right now, it's just dropped down to 650 Fahrenheit, and I want it at 680, and then I know it's going to overshoot. Yep, it's overshooting and going up to 710, so it's just not a very consistent tip, so I don't use it all the time. Next, would put the diodes in. Okay, now we're going to do the ferrite core, little mini inductors. So now we're going to grab 2 resistor leads, or 1 resistor lead at a time, since I only picked one up. Take it, thread it through the center of the core, bend the lead down to lock the core in place, and find its spot on the board. And he uses a resistor symbol for it, but underneath he has the letters FER to indicate ferrite. I think the official symbol for a ferrite core is an L, but I wouldn't swear to that in a court of law. And I got this one kind of cattywampus. There we go. And I like to solder the ferrite cores as soon as I put them on the board, just because since the cores are not attached to the wire passing through them, if these happen to fall out, the ferrite core, I guarantee, will roll that way about 6 feet and I'll never find it. So I'm very paranoid about ferrite cores, because I have lost them in the deep, dark past. In the deep, dark past, when there was no such thing as online ordering, and I couldn't get a new one the next day, I'd have to drive all the way to Radio Shack or Lafayette Electronics, or hitch a ride there. And then, if they had one in stock, and then if I could afford it. So, a lot of reasons to be careful with your ferrite cores. That piece of solder, that piece of lead I just picked up had some solder on it, so I didn't want to use that one. Alright, so that's actually bag 1 empty. Now we're going to open mainboard bag B. All the capacitors, transistors, the power header for the power cable, and a couple of pin headers for mounting the 2 boards together. So first we have to detangle the capacitors from everything. Oops, and that landed in my lap, not on the floor, fortunately. Alright, First we're going to do all the 100 nanofarad, the 104s. And there should be 11 of them, so let me count them out on the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Even though I've got bags of these types of caps, I've probably got 200 monocores lying around, but nice to use theirs if I can. Okay, going fast again as I put these in. And that's all the capacitors. And next are the ICs, but I'm going to skip it or stop right now for this evening. Cats need to get fed. Next are the IC sockets and then the ICs, both on the main board and on the control board. Alright, all the sockets are installed. Now let's populate them, but as we do that, let's take a look at what they are. So first, two Texas Instrument TL074CNs. So those are two op amps. Then we've got some more Texas Instrument parts. Befaco seems to use a lot of TI parts, which is nice, I guess. I'm glad they found something that works for them. CD401, CD401, 3 Baker Echo. So it's a CMOS flip-flop, 2 identical independent data type flip-flop. Oh, and there are 2 of those. There are 3 of those, 3 flip-flops. And then something I can barely read. It's another TI part. TL072 Charlie Papa. So this is a dual input op amp, very fast acting. Okay, so it's a bunch of op amps and flip-flops. Now let's find the voltage regulator. Yep, that floating on the end of my solder is a bit of ribbon material from a ribbon mic I built from Austin Ribbon Mics a few months ago, and it's still hanging around. This is such fine and delicate metal. Watch that video, I'll link it in the description, and you can see how much of a challenge it is to make a ribbon mic, because that material is so delicate. Okay, now we'll do the pin headers. And now the main board's done. And again, I'll just highlight that a picture would have been nice. Just make lots and lots of pictures. Pictures don't cost anything extra. Now we have control board bag A. Which is all the passive electronic components, LEDs and pin headers. Okay, that's all the electronics parts for the most part. There are a couple, I think there's one more. Actually, that is all the electronics. Now we're going to do the mechanical components. I mean, of course, the LEDs are electronic, but they go on when we put the front panel on. So this is control bag B, and first thing we're going to do is the IC, but we already did that. Female pin headers. Now the spacers. Secure the spacers on the control board with the main body of the spacer on the component side and the nut on the opposite side. So let's find our spacers. We have 1, 2, 3 spacers, and fortunately 1, 2, 3 nuts. Now the question is, where exactly do they go? And I think I know the answer to that, but if you look on the board, this silver circle, and this silver circle have nothing attached to them. These others, where jacks and otherwise go, have solder points and leads connecting to them. So we know that these are where the spacers go. Again, though I will say it, a picture, a digital photograph online would show that very quickly and easily, and no one would ever have to guess, and it wouldn't cost you more than dropping a nut on the shop floor. Fortunately, I've got boxes and boxes of nuts and bolts, so if I can't find this one, I'm not too worried about it. Let me go find it. Hardly worth talking about. It was right there on the floor right at my feet. I'm not too worried about the torque on these. They're not going to have much strain on them. And again, since I don't gig with this stuff, I don't have to worry about them coming loose with vibration on the road or on stage. Though this will either be in the shop or in my music studio, not moving anywhere. Okay, there go the spacers. Now we do the faders. And we also try and figure out why my pipe won't stay lit tonight. I think it's got a crack in it. So let's see how these faders go on. They should be keyed. One would think they're keyed. So they're going to go on this side, of course. And they are keyed. There's one tab at the top, 2 tabs at the bottom. So that's easy. And they go in. Okay, so they're not going to go completely flush. You'll see here there is a gap where it's sitting on top of the pin headers. And then on the other fader spots that'll be sitting on top of the IC pins. And the back is a composite material, so it shouldn't be grounding or shorting anything except for these little tabs, except for the fold-over security tabs. I'm going to keep an eye on that and see if they come close to any of the pins. I can't just lay this down because the control handle sticks way out, so we'll just solder. And this is another case where use a lot of solder, because these, you're going to be pulling the sliders up and down all the time, and you want to make sure they stay firmly in place. So I'm just going to solder one leg, because as you can see here, the other legs meet with the other faders. So we'll just do one at a time, and we'll try not to LED at the same time. And again, I'm going to look under here. No, it doesn't appear to be grounding, but it also doesn't sit flat. Gosh. These don't sit flat because they're rocking on the pins from this socket. Huh. Don't particularly like that. But obviously not a ton to do about it. But it might make the, now as I think about it, it might make the front panel not quite as flat as one would want. Now I can solder this other pin too. Ah, come on. See, that's not just not. I'm not real happy with that, because as you can see, I've got it, or maybe you can see, I've got it at a slight angle. I'm going to try and level it out a little bit. That felt good. That's better. It's not great. Again, I like Befaco's design quite a bit, but I think they need to think about how to rest these faders so they're all flat to the board. As, I don't know if you can see this, I say that all the time. I don't know if you can see this. There's a little shoulder here on each securing leg. And I would love that shoulder to be flat on the PCB. And I think that's the intention of the designer of the faders, is that's how they'll be mounted. But the way this board has solder points right beneath it, or running underneath the faders, kind of keeps you from being able to do that. I guess I could flush cut all the way down. I could trim all the way down, but I really hate doing that too. So, lesser of two evils is to just mount these and then by hand adjust them so they appear to be level. Okay, that one almost went level by itself. Nope, not quite. This board is shaved so close to this solder point. Fortunately, it's not a conductive part. It's just a securing solder point, but I think you could have gone one more HU out and given these parts room to breathe. One tricky thing, semi-tricky, is the actual potentiometer or fader connections are here, and you might forget about them because you're busy soldering the securing legs and you forget about the contact pins. So you don't want to do that. Okay, all the faders are installed. Let's run them up and down. They all feel smooth and secure, and they're all relatively level. Now we're going to do the final assembly bits, which is, of course, in some ways the easiest and in some ways the hardest. This is making sure that we get all the front panel components installed correctly. I will just set all the LEDs in. How many LEDs are there? It looks like there's just 5. And again, the LEDs Befaco uses on all the kits I've done so far have the shoulders, so it's narrower at the point that goes through the control panel than it is at the base. I'm sorry, my hat just fell off and I couldn't find it, which is a weird thing to say, but it's true. So we drop the LEDs in and we do not solder them yet. And of course we do try and remember the polarity. Pot will go here, and it doesn't have any bolt on it already. I mean, nut on it already, so it can just set in there like that for right now. And then we're going to do the toggle switch. But I got to set this down for a minute to do that. And you get rid of the locking tab, and I get rid of the lock washer because, again, for me it's just not worth it. It'll go up here, and when I say not worth it, I mean I don't like the way it looks. It certainly functions appropriately, the lock washer and so on. I just think it looks ugly. Now the push button. Now we've got all the mechanical components roughly there. We're not going to do anything with them yet. Now we're going to get the bag of jacks. Here it is, right in front of me. If it had been a snake, it had bit me, to quote Buckaroo Banzai. Now fortunately, I don't have to take the nuts off of all of them, they're already off. Now we're going to put all these jacks, and they've got 3 pins, in, out, and a common ground plane pin, and they share a pin, so the bottom jack shares the center pin with the jack right above it. I mean the ground pin with the jack right above it. So right in there, the 2 third pins join in one central hole. Okay, so all the parts are on the board. They're not secured, but they're on the board. Now we're going to take the front panel And what I like to call this step is determining who's the boss. Because you're trying to find which of the components is the tallest. Because the one that's the tallest is going to set the distance you want these, nope, I'm not in that one, that you want to set your lock nuts to, and then start soldering the board. Okay, now if we look and see who controls height, it looks like this switch, this one right here, is the tallest component on the board, even with that lock nut taken off. So even though these are pretty flat too, this is a pretty even board. The components are pretty even. So what I'm going to do is first I'm going to bring up a picture, and I'm bringing up the picture just so I can see which color panel nut. Okay, so I've got two corners with lock nuts just very loosely secured. So next I'm going to solder those two components. Gotta get my fingers arranged, because the problem is I can't really hold this with anything or set it down because of the long fader arms. So we'll just tack that one pin and tack this one pin. Okay, with those tacked down, I'm going to tighten those panel nuts, snug them down, not tight, just snug. And now we're going to go ahead and solder all the rest of the junk on this board. Actually, no, wait. I was saying, oh, I got to put the LEDs through. Well, they fell through all on their own, all natural. Except for this one. There we go. Yeah, I've had no problems getting these LEDs to go through. I thought when I did my first Befaco using those shoulder LEDs, I thought that'd be a problem, but it's not a problem at all. And that's that. Now I'm going to put all the panel nuts on. Now I just scraped the front panel. That was really stupid of me. Okay, now we're going to do the final mating between the two boards. And how they go, of course, is based on, here are the two spacers, one spacer. Two spacer hole, one spacer hole. So that's easy, you can't get really confused on that. And we're going to match up the pin headers. Then apply some force. Not much force was needed, that was nice. Get our screws. And there we have it. Oh, no, not quite. Got two more steps. First, and a cap for the potentiometer, a cheap cap. So the camera's cut out. I didn't even notice as usual. So we put, I don't even know when it stopped, so we'll have to figure that out later. So here it is. Everything's on. The caps for the fader tips and the potentiometer knob are pretty cheap plastic. They're not really great. They're not up to the quality of all the other components on the board. But nice and solid. There's the way it all goes together. And the faders move smoothly. Again, it's a good build. It's one of the more, it's a little more components or more resistors. It's not harder or more complex than other units, but there are a lot of components on the board, so it takes more time simply putting them together. But it's a good looking unit. Now all we have to do is set it in the rack and power it up and see how she works. So we've got her set up in the shop test eurorack. We're not using any, we're using, I'm sorry, let me pan over, let me zoom back a little bit. We're using a Befaco MIDI to CV and MIDI to gate to trigger this. So we've got MIDI coming off this little keyboard going in, triggering as the input trigger, switch set to trigger. The output is not this pink wire, it's this red wire that's going to the oscilloscope, which we'll pan over to in a little bit. So that's what we're doing. You can also trigger by hitting that button, and as you hold it down it will continue to re-trigger. So if you want to test things and adjust stuff, that's what you would do. So let me zoom in tight here, and as you can see I've got a little attack, no decay, long sustain, and moderate release. So if I trigger, you'll be watching the LEDs along here. If I trigger with the MIDI keyboard, you can see it sequences through attack, decay, sustain, release, and the release is staying on, that LED is staying on longer. Now if I bring up the attack fader, attack LED stays on, then it goes through the rest of the sequence. If we put everything roughly in the middle, A, and then it just goes right across. Let me pull decay up a little higher. Attack and then across. I'm not quite sure why it's doing that, but that could be the release segment is way too long. And also because it's because I'm not holding the key down. And it's going to continue to sustain as long as it's getting the trigger input, and the MIDI thing is sending the trigger input. It won't send a note off. I mean, it won't stop sending the trigger until it gets a note off, and there's the note off, and it goes through the rest. So let's go back to moderate for everything, and I hold it down, attack, decay, sustain until I let go, and then it releases. So that's easy to understand, and it works really well. Now let's look at the oscilloscope tray. Again, we've got all the sliders about 1/4 of the way up. So there's attack, decay, sustain. You can see it's staying above the 0 voltage by about 5 volts. I think that's what it's set on. And there it goes away. Now if I change it, I drop the attack real low, increase the decay, take the sustain down, take the release down, you get a much different shape. And as I hold it, the decay does that, and then it releases. If I tap it fast, you can see that release, or the decay segment, is almost flat at the top. That's interesting. Now I've taken decay all the way off, so it's a real sharp attack, a little bit of sustain, and then a slow release. Let me take the release all the way up, like you might do in an atmospheric patch, and there it goes. There it slowly goes back to 0 volts. In fact, I'm going to kill it because that's boring. And you can adjust the shape. Let me set to a moderate example again. You can adjust the shape of the wave. I don't know if you caught that. The decay segment has a curve to it now because I've turned the shape knob way to the right. Let me put a little more sustain in there. Make the attack really long. You can see it's taken forever. I don't know if you can, if you're noticing, it's inching up very slowly when I've got the shape all the way to the right and the attack parameter all the way full up. I mean, it's still on attack. Still on attack, still on attack. So you can get an incredibly slow opening. Say, if you have an evolving filter that you want to do something that does something as over time, and the attack just goes on forever, and it evolves as it grows. That can be pretty neat. Now I'm moderate again. But still, you got a lot of attack control here, and a lot of range. Now I've changed decay to be really high too. Let me change the shaper back to the middle. Now tap really fast, and you can see with my decay still set high, it never really goes to 0 when I'm tapping. Now I've taken decay all the way out. I'll take sustain all the way out too, and there we have a nice, almost saw. So it's a very good unit. Works well, does exactly what you would expect. And I think as interesting as anything else in this unit, in fact probably the most interesting thing, because it's an ADSR and they work the way ADSRs work. But these, the ability to pull a gate trigger for each stage, and then also control voltage to affect each stage too. So that means you can do a lot more interesting things directly with each individual segment of the envelope. But again, you can read more in depth. It works very well. Easy to understand, easy to use. I think that it would be a good addition to your rack, and it was a pretty fun kit. So thanks for watching.